Hi, we are Team SV1. We're going to talk about the survivable social network on chip app that we developed throughout this semester. Our team consists of myself, Shiva, Meeta, Muyun, and Zilin. First, let me start with the vision of our SSNOC app. Next, we will cover the software architecture that we used throughout this project. Next, there will be a short demo of the functionalities that we implemented throughout this project. Next, we will talk about the quality attributes and the software engineering practices that we adopt throughout the semester. Last but not the least, we will talk about the lessons that we learned while we were working together for this project. Let's start with the team's vision of the SSNOC. Imagine that there is a natural disaster in a CMU campus. There is no electricity and the cellular network is down. You want to make sure that your friends are okay. You also need immediate help because you hurt yourself. What would you do in this situation? Here is where our app comes into the picture. Our app helps to connect people in the wake of a disaster. By indicating the status for each person, we would know who is in dire need of help by looking at the emergency status. We also provide interactive and immediate support by creating events and notifying nearby citizens. This will ensure that the person who is in dire need of help gets help immediately. We also want to maximize efficiency and have a very simple UI so that the user does not get bogged down by details on how to use the app. So overall, our vision is to be ready and be prepared to face emergency and help as much as people as we can. This is like the overview of our app, and we can do a lot of things like notifying nearby citizens, chatting with the other people in the directory, adding people to the community, looking at the map to see who's near you, searching for information, recording an emergency audio, or uploading an emergency picture.
Hi, I'm Salim. I will introduce our software architecture design and some important technical decisions to you. Firstly, our architecture style is client-server style. There is one server and many clients. The server communicates with the clients through the computer network. This diagram illustrates how we deploy the server and the clients. The server is deployed on the board black, and the clients are many browsers on users' mobile phones. In addition to the client-server style, we adopted MVC pattern to implement our software system. This diagram shows how our system works. The clients access the server with some HTTP requests, and once the server receives this request, it will use a router to dispatch the requests, and then the corresponding controller will handle the request. To do with the target business logic, the controller will probably take advantage of the models. The models are well connected with the database. They implement some operations to operations on the database. Finally, the controller will use the view to render the web page and return the result. As I mentioned just now, our server is deployed on the Big Bomb board black. On the chip, we installed a Debian Linux operating system as a platform to support our application. There is also a Wi-Fi network gate to create a local wireless network. Besides, since our system is supposed to be used after a disaster, so it should be durable after the disaster. Okay, this is the battery we used to power our system. Now, let me introduce our important technique decisions to you. For our front end, we used HTML5, JavaScript, and jQuery to create the responsive web pages, and they are also used to enhance the user's experience. Well, to make our application more friendly, we used the Bootstrap as our CSS framework. The HTML5 also help us to implement some features like recording the audio and get the location of the user. So HTML5 is necessary for our application. As for the backend, well, We used the Node.js plus Express as our backend framework to build the server. Besides, we used the Jade as the template engine and the socket I/O to pass the message between the clients and the server. Finally, we used the Circlet Lite 3 as our database. It's a lightweight database and it's very easy to use. The next part is our demo. Please enjoy it. With this SSNOC, we will never be hungry again. Oh, I'm starving.
I'm dying for food.
Wait, I have an idea. Oh, we are starving. We need help. We need food. Anyone help?
Oh, someone sent SOS? They are hungry. Oh, here are some food. I can have them.
Oh, someone posted on SSNOC that there's food in the activity room.
Whoa, that's so cool.
Let's
Whoa,
go.
let's go.
Next, I will reveal the quality attributes our team focused on during this semester. We have achieved multiple quality attributes including modularity, mobility, and usability. For modularity, we architectured our code into a modular way. Throughout the semester, we continued to add new features into the existing feature set. And because our code is structured in such a modular way, it was extremely easy to add new features into the existing set. For mobility, our end system is a ready-to-go system. It doesn't require hosting a server on a computer, and we host our server on a BeagleBone Blackboard that can be plugged in directly and is ready to go. For usability, we tailored our use cases for best usability. For our location features, we added support for taking pictures and recording audio to share an event. There are some quality attributes that our team can improve on, including compatibility and fault tolerance. For compatibility, our location feature is currently supported on Android devices only. Given more time, we can extend this feature so that it's supported on iOS devices also. For fault tolerance, our system is currently hosted on a single server, so it's subject to single point of failure. We can also improve on this set and consider hosting our server on a cloud platform.
Our team takes the hybrid method of Lean and Agile process. We pick multiple practices from Scrum, Kanban, and XP. We deliver our work incrementally and iteratively. Work is prioritized by risks. This will prevent the situation that will meet the highest risk at the end of a sprint. For example, in iteration 5, our own use case needs to use some audio recording APIs. The highest risk is that we may meet some compatible problem with the mobile browser. So we first wrote the audio recording code and tested it with mobile devices. iPhone's browser went to crash for this code, and we finally found that only the Chrome on Android device poses this feature. So if we didn't follow the risk-driven rule, we may not have enough time to deal with this problem. We use Trello board to visualize the workflow. Everybody can see the iteration plan and each team member's individual task and contribution. As our team don't have much more common available time slots, with this Trello board, we can collaborate and get to know what other people's work better. At the beginning of each iteration, we had a meeting for estimation and iteration planning. We used Planning Poker to achieve a relative unbiased workload estimation. Meanwhile, by discussing and evaluating the workload of each use case and deliverable, we can understand the requirement better. We also do pair programming. Usually, two members were responsible for one use case or function. By sitting together and coding together, we had better discipline. We learned from each other, enjoy group work better, and also improve the code reliability. At the end of each iteration, we had a retrospective meeting, during which we discussed what was going well and what was not so good. This really helped a lot. We found our problems and then solved them. For example, our team lacked organized at the beginning, so we find more meeting slots to work together, use Trello to track everybody's work, discuss in Google Hangout if we cannot meet face-to-face. When we found our code was not so reliable, we did pair programming, code review, more testing, and code refactoring when necessary. So in retrospective, we find out what practices are good for us.